Hi, I'm Vivian Taylor. I'm a mercury researcher at Dartmouth College, and I study mercury contamination in streams, lakes, and the ocean.
I'm Christine Gardner. I'm a lab technician at Dartmouth College, and our lab studies marine and aquatic pollution and bioaccumulation in organisms.
We are collaborators on the Dragonfly Mercury Project, which engages communities all over the United States in collecting dragonfly nymphs, which we use to monitor mercury pollution.
We're partners with the Appalachian Mountain Club, who collaborate with other scientists in Merrimack and Lake Champlain.
We are currently standing in the Life Sciences building, and we wanted to show you today what happens to dragonfly samples which come to the lab for analysis.
First, we unpack them off the coolers and then put them in the freezer for temporary storage. When we're ready to start processing, we double check everything very thoroughly to make sure we have all the information, like the field data sheets and the sample IDs.
The first thing I do is choose a sample set from the freezer, then bring them over to our clean lab bench where I use a ruler to measure their length and use a taxonomic key to check their family ID and make notes for our database. Then we weigh them on a balance, which is a very accurate scale. This gives us their wet weight. Pop quiz: how much of a dragonfly is water? Based on the DMP data over the past several years, it's not too different from our own percentage, about 85% water. For reference, humans are 70% water. Next, we dry the samples and then we weigh them again. We need to know their dry weight so that when we get the mercury results back, we can convert them to a dry weight basis. This is a step that helps us compare among all the different dragonflies and also compare our data to other organisms, which are usually analyzed as dry material. Next, the dried dragonflies are ground up into smaller pieces so that they can all fit on the instrument. They look a lot like ground pepper when they're done. Now we are ready to start analyzing the amount of mercury in each dragonfly. To do that, we're going to take the samples over to an instrument laboratory in the Earth Sciences department. We're going to use an instrument that's called the Direct Mercury Analyzer. We'll call it the DMA for short. The DMA is an instrument that will be able to tell us how much mercury is in each sample. Every time we run this instrument, we have to prove that it's working correctly. And the best way we do this is called quality control. We test the instrument to see if it's getting the right answers, the right amount of mercury, for all these standards. When it passes the test, we're ready to start analyzing the dragonfly samples. So finally, here the DMA is picking up a boat with a dragonfly sample. It's pretty cool, it's automated, and the DMA takes it from here. It picks up the boat and moves it into a part of the instrument that heats it up to 600 degrees Celsius. Now we have all the mercury from that dragonfly in gaseous form, and that gas is passed along to a tube that is filled with gold-coated sand. The mercury sticks to the gold-coated sand. Mercury likes to stick to gold. We're using that to our advantage. Once the entire sample has been heated and all the mercury is released and attached to the gold, then the gold-coated sand is heated very quickly to release all the mercury from it in one big pulse. That big pulse of gaseous mercury travels into a sensor that shines a specific wavelength of light on it. The amount of light absorbed by the mercury tells us how much mercury was in the sample. This is kind of like when a light gets blocked by smoke in the air. The light coming through it is dimmer. How much dimmer depends on how much smoke is in the air. Here we can tell how much mercury there is by how much light it absorbs. Luckily, the DMA can do all the math for us. It creates a calibration curve with a peak, and it calculates how much mercury was in the sample, and puts that number in nanograms of mercury into a report for us.
A lot goes into getting that one number from that one dragonfly. From when you collect the samples to the mercury concentration that's come back to you, the samples have been through the mail, on the lab bench, been frozen, dried, ground up, turned into a gas, and finally the concentration's read on the DMA.
We enjoyed giving you a look behind the scenes at the lab. The data that we collect as part of this project allows us to monitor mercury all over the United States as well as in your watershed.